You're in the yogurt corner. All right, here we go. So, cosecant, that's like what? 1 over sine. So this is like really 3 over the sine of x minus the sine of x. Actually, here, tap the brakes. Minus the sine of x equals -2. Love it. Right? Not so much? Okay. Now, do we like fractions? I mean, I do. Okay. But when we're solving, I don't like them. So I'm going to multiply this entire equation here by sine of x. So this first part becomes 3. The next part becomes minus sine squared of x. And the right side becomes -2 sine of x. I like to get everything onto one side here now. So I'm going to put everything on the right side because then I've got a positive sine squared of x. Factor. I need a -3 and a +1. First equation. Second equation. Add 3 to the left one, subtract 1 from the right one. Unit circle time. Sine of x. Where is sine of x equal to 3 on my unit circle? Nowhere. Sine of x unit circle, where is that equal to -1? First lap, unit circle, where is sine of x equal to -1? 3 pi over 2. And that is my answer. Okay? Now, a couple of things about the formatives that I saw. And by the way, if you haven't turned in your formative yet, make sure you turn in your formative. Okay? So we scanned a couple of them in, just so that you could see what we're talking about. Okay? When you are simplifying, you need to be clear and expressive in your thinking. Don't assume that I know what you're talking about. Okay? In this particular problem, where it was tangent squared of x over 1 plus tangent of x, the first thing that I would do, tangent squared down here too. First thing I would do is I would change 1 plus tangent of x to secant squared of x. Which this person did, and this person did. Then I would change tangent of x to sine squared of x over cosine squared of x. and that is still over secant squared, which here now I could make secant squared 1 over cosine squared of x. This person did not. This person did not. Up here, this person did. Okay. Then I would write this as sine squared of x over cosine squared of x times cosine squared of x over 1 as a separate step so that I can clearly see my thinking. On the majority of these, they went right to, they skipped this part, and went right to the end. Okay. And then finally at the tail end, this is just sine squared of x. Okay. Especially starting today, you need to be clear and you need to show, bless you, you need to show all of your work. Okay? I am, unfortunately, for those of you that are my grading students, I am a show work kind of a person. Okay? And grading these, I was the nicest of the three. So imagine what Roth and Hill think about showing work. Okay? All right? Many text messages were floating around as we were correcting them below these last few days. Okay? Show your work. Because what's going to happen today is today we are going to start proving identities. And so in order to prove the identities, your work has to flow. It can't just jump right to the end. Okay? The difference between today and whenever it was the last time you had pre-calc is the last time you had pre-calc, we gave you an identity. So or I shouldn't say that, we gave you an expression. So I gave you this. That's all you would see. And you would go through and you would simplify it. Okay? Well, now I'm telling you that if you simplify this, you should get that. You should get 2. Okay? So you know when you should stop. You know if you're right or not. Because if you don't get 2 here, you haven't, 1, gone far enough, or 2, you screwed up somewhere along the way. Okay? All right? So, let's work this out. How would you go about, and I would look over here first. I would start on that side because I can do more with that side than I can do with just 2. What would you do on the left side there? Get a common denominator. Love it. So my common denominator would be x minus 1, x plus 1. Top left one is missing an x plus 1. Top right one is missing an x minus 1. Agree? Okay. Then I can combine the tops. Still over my common denominator. Yes? What jumps out at me right now is the fact that both of the terms on top have this x squared minus 1 term in them, right? So let's factor that out. Instead of doing a double distributive twice, let's factor that out first, and maybe things will get simplified a little bit more for us. So what's left over then is x plus 1 minus x minus 1. Right? Red. Can I do anything with red? You sure?
Can you distribute the negative sign?
Okay. So a little side action here. X plus 1 minus x, and then plus 1 again, right? So that really is just 2. Now what? Don't want to. What? Okay, I could distribute for the denominator, or I could factor on the top, right? One or two of them. I could factor the top to be 2 times x minus 1 times x plus 1, or I could distribute on the bottom and get x squared minus 1. Yes. And then these cancel each other out. So that leaves me with 2, which is important because that is what I needed it to be. Okay. Again, I will tell you the problem and the answer. You just have to fill in how to get there. Okay? And we live by one simple rule. And that one simple rule is you can only work one side. We're not working both sides at the same time. We're only going to work one side at a time. And once we pick that side, we're going to stick with that side, and we're going to keep going on that side until we get to the other side. Okay? If I'm taking the family down to the Brewer game at what used to be Miller Park, but is still Miller Park for yet another season, I'm not going to stop in Oshkosh and say, hey, we're here, kids, let's go. Okay? Because I'm not there yet. I got to get all the way there. Okay? Now, side note, you want to pick the ugly looking side. Okay? You want to pick that side and work that one, because you'll be able to do more with it. Okay? Just remember, we cannot add, subtract, multiply, or divide to both sides. We're only working one side. Okay? So, with that being said, let's look at tangent plus cotangent equals secant cosecant. Which side appears to be more complicated, uglier, more scary? Which side? The right side? Do we agree that the right side is more difficult than the left side? Sometimes it doesn't matter. Sometimes it does. Which one's more scarier to you in terms of fractions, let's say? Because tangent and cotangent are both really a fraction, right? Is multiplying fractions easier to do than adding a fraction, or is adding easier than multiplying? Multiplying is easier, right? So I would stay away from the multiplying side, and I would go to the adding side. Okay? So I would actually say, and I would, with great certainty, that the left side is more complicated than the right side. Okay? Because tangent is sine over cosine, and cotangent is cosine over sine. What are we thinking? Common denominator. What common denominator would you like to go with? Need to have a cosine, right? Need to have a sine. So cosine sine. What's missing? Left one. What's missing? Right one. Okay. So this becomes sine squared of x plus cosine squared of x all over cosine sine.
You have to show that.
Yes. Yes. That's that whole, we gotta see what you're thinking. Okay? Sine squared plus cosine squared. That should be ringing a bell in your brain. That's just one. This is 1 over cosine times 1 over sine, right? Which is 1 over cosine is secant, 1 over sine is cosecant, which is what I needed it to be.
Did you just break that part?
Yep, because I can, because it's multiplication. Okay? What I'd like you to do now is I'd like you to try this one. All right, so from up front here, from the front row, it's looking like everybody worked left side, as the more complicated side. So let's work left side here, because it's just fact, for lack of a matter of fact, it's just more complicated. Okay? So if I distribute in that sign, because that's legal, I can distribute into a parentheses, I get sine of x cotangent of x plus sine of x cosine of x tangent of x. Right? Okay. Cotangent is cosine over sine. Tangent of x is sine over cosine. Agree? This sine cancels out that sine, leaving me with cosine. This cosine cancels out that cosine because everything's being multiplied there, leaving me with sine squared.
There's a lot of extra steps. But I'm not like, got it. I'm just supposed to write out the sine of x and then sine of x and then put sine squared of x.
I did.
Okay. I meant like after that, like to make it clear. And
I did.
No, like you put them together.
I did. It's right there. It's in a box.
But you just put them together. That's what I was asking before. Do we have to write sine of x and sine of x before we can write sine squared of x?
No.
Oh, that's what I was asking before.
Okay.
Yeah.
All right. Tangent plus secant, or cosine and 1 over minus sine, or 1 minus sine, over 1 minus sine. Which side do you think looks more complicated? Which one? Right side? Left side? Left side? All right, let's work left side. So tangent is sine over cosine. Secant is 1 over cosine. Last one. Right? One plus sine over cosine. Right? Uh-oh. It's upside down. Actually, and there's a plus sign and not a minus sign. Okay? So, I can multiply this top by 1 minus sine, right? But if I do that, I have to multiply the bottom by 1 minus sine. Correct? On top, I get 1 plus sine times 1 minus sine, which is 1 minus sine squared of x. On the bottom, I get cosine of x times 1 minus sine of x. What can I do with the top? It's cosine squared of x. The cosine on the bottom cancels out 1 on the top. Oops, I'm going to put it in a different color because yellow is not the favorablest color. Leaving me with cosine of x on top, correct? Which is cosine of x then over 1 minus sine of x, which is what I needed it to be. Thanks for playing along.